Hello everybody, this is Miss Bryant, and today we're going to go over Lesson 8. Lesson 8 is rotation patterns. Our learning goal for today is to be able to rotate figures in a plane, and our success criteria, knowing whether or not you're able to do it, is basically being able to describe how to move one part of a figure to another using what's known as a rigid transformation. So we're going to start off with our warm-up for today. So here's our warm-up. We have here a right isosceles triangle, and we're going to answer questions 1, 2, 3, and 4. I'm going to show you how to do those. Number 1 says to rotate triangle ABC 90 degrees clockwise around point B. So again, remember, we have to know the directions, the degrees, and the center that we're rotating around. So what we're going to do is we're going to get our patty paper or notebook paper, whatever paper you have, especially when you're using your iPad. We're going to draw our original shape. Now, again, those of you who had me before, this is something that I've told you that I like to do, and you can do it as well, especially if it helps you. The point we're rotating around is point B, so what I like to do is draw a straight line going from it and draw my right angle box. I use this to help make sure that I rotate it 90 degrees. And I believe the question told me to go clockwise, so I'm going to go down. Because again, clockwise is going this way. Counterclockwise is going this way, right? So pencil on point B, and I'm going to go down 90 degrees. And I know I went 90 degrees because I form another 90-degree angle. I'm going to do that again. So looking at my little box that I drew, I rotate it until it's perfectly straight again like it was originally. And now it is perfectly straight. So I'm going to highlight my new point right there, draw my new figure, and this is a 90-degree clockwise. That was question number 1. Question number 2 says to rotate the same shape 180 degrees clockwise around point B. So I'm going to take my shape, since I already have it traced up here. I'm going to realign it with the original. I have my new shape here from question number 1, so I know that's 90 degrees. And with 180, 180 is 2 sets of 90 degrees. So here's 1, and here's 2. So I'm going to use my marker. And so this is 180 degrees clockwise. And if you remember from yesterday's notes, when you're rotating 180 degrees, it doesn't matter if it's clockwise or counterclockwise. You're going to basically get the same results. All right. Now, question number 3. We'll go back and look at our questions. Question number 3 says I'm rotating 270 degrees clockwise, again, around point B. And 270 degrees is basically 3 sets of 90. I've already rotated 2 sets of 90. I just have to do that third one. So I'm going to line up again with my original shape, pencil on point B. I'm going to rotate it 1 set, 2 sets, and now my third set of 90 degrees. And so there is what it looks like when I rotate my shape according to what questions 1, 2, and 3 ask me to do. Now, for question 4, it says, what would it look like when you rotate the 4 triangles 90 degrees clockwise around B, rotated 180 degrees around B, or rotated 270 degrees around B? Well, if I was to rotate this whole entire shape 90 degrees, 180 or 270, basically the rotation is just going to be an interchange of the 4 triangles that I've created. They're just going to shift around. So if I was to take this all and rotate it 90 degrees, this green would be here, pink would be here, blue would be here, and black would be there. So it'll just keep turning the shape around, kind of like a spin wheel. Okay. All right. So hopefully that demonstration helped you to, again, reinforce how to rotate clockwise, what it looks like, and maybe, hopefully, that little strategy that I showed you here will help you with rotation in the future on a coordinate grid. And now, Miss Looney is coming in to do activity 1 with you guys.
Okay, for our first activity, we are going to be actually rotating some segments. So we'll start with the first one, which is asking you to rotate segment CD 180 degrees around D. Draw the image and label the image as C as A. So I'm going to start by using some patty paper, and you probably already have some paper out or something that you're going to use to do that with. And the first question, again, is we're going to rotate the segment CD 180 degrees around point D, and we're going to draw the image and label the image as C as A. So first thing we want to do is draw that segment. So here is our segment CD. And it's very important that you go ahead and label that. And so we're going to rotate it 180 degrees about the point D. So what you need to do, as Mrs. Bryant had just shown you about drawing that right angle, we're going to draw a right angle about the point that we are going to be rotating around. So I'm going to draw a line here, and I'm going to make this a 90-degree angle. All right, so from this point, I'm going to rotate it 180 degrees. So there's one, and then I'm going to rotate it again until I make that 90-degree angle. So now our segment is here, and so now we're going to label the C. This C now becomes A. So now we have the segment, and I'm going to go ahead and draw that line. And so now here we have our new image of A. Okay. Now for question number 2, we're going to rotate the same segment 180 degrees. This time we're going to rotate it around point E. And we're going to draw the image, and now we're going to label the image of C as B and the image of D as F. So again, I'm going to just use a fresh piece of patty paper. I'm going to draw the segment CD. And this time we want to rotate it around the point E. So don't forget to label your segment. And here is point E. So this time we are actually rotating it around a point that is not on the segment. So again, I'm going to draw a line here. I'm going to create that right angle. And we're going to rotate it 180 degrees. So point on E. Okay, I'm going to rotate it till I get that 90-degree angle. So here's one. And here's two. So now we've created a new segment. This becomes so now C and B now become D and F. So I'm going to label this C as F. I'm going to label C as B and D as F. Okay, and so I'm going to draw that image. So now I've created a new segment, FB. So now that I've created that, you should be able to see somewhat of a pattern that you're beginning to see with that. Question number 3 says I'm going to rotate segment CD 180 degrees. This time I'm going to rotate it around the midpoint of G. And then it's asking the question, what is the image of C once I do that? So I'm going to take a pad of paper. I'm going to draw my segment CD. And here is my midpoint G. So everyone knows what midpoint means. Halfway between the segment CD. Divides it in half. So from this segment, from the midpoint, I'm going to do the same thing I did before so I can get some accurate, I can accurately rotate it 180 degrees. So I'm drawing my 90-degree angle. I'm going to place my point on G, and I'm going to rotate it. Okay, here. And here. So if you notice, it ends up on the same line, but I do have to, so what is the image of C once I've done that? Okay, so I'm going to take it back here. So what happened when I rotated it back around? The D became C and the C became D. So we have C here. Excuse me. Okay. So we have C, rotated here, rotated here. C became D and D became C. But it ended up being the same segment. All right. So for question number 4, it asks, what happens when you rotate a segment 180 degrees around a point? So for each one of these, we rotated the same segment CD about some point. When we did the first one, we rotated around the point D, and we ended up pretty much on that same line. When we rotated about E, which was not on that line, we noticed what? That it ended up being a segment not connected to that particular line. And it actually formed segment FB, which ends up being a parallel line to segment CD. And then when we rotated about the midpoint, we ended up also on that same line. It just extended. It became the same line. Okay. All right, so now we're going to have Ms. Wallace come and explain the next activity.
Hi guys, I'm Mrs. Wallace. So we're going to be doing activity 3 together. And this activity is wanting us to use this image to look at these 4 questions. Okay, so we're going to be using rigid transformations. Remember, that means that none of the lines are getting wiggly or changing and the shape is staying the same to make patterns. So here's a diagram built with 3 different transformations of triangle ABC. So this is our original, okay? I'm going to make him a different color just so you know ABC is our original. All right, 3 different transformations of the triangle. So I'm going to use my patty paper to trace triangle ABC to help me as I'm doing these different transformations. Now, I can already kind of tell that, you know, this is kind of rotations being turned around. So I'm thinking that that's the transformation I'm going to use. Translation would be a slide, okay, in a direction, and the triangle is not changing. Well, none of these are a slide, so that kind of rules out translations. Reflection is a flip, so if I flip my patty paper, that's kind of what the triangle should be looking like. None of these triangles are looking like that, or I could flip the paper this way, okay, but none of the triangles are looking like this. So that kind of leaves me with rotating. Now, the important part about rotating, remember, is you have to identify the center of rotations. A lot of times it is one of our corners, so like A or B or C, okay? And as I can tell, none of these are going to quite get me to any of the other triangles. The other option is to figure out the center of where all this rotating is taking place. So a lot of times it's the origin on a grid, 0, 0. In this particular case, I'm going to be looking at the center of my square. So if I keep my triangle on ABC, the original, and I put my pen or pencil on the center of the square on my patty paper, and I start turning, you'll see that it actually ends up lining up with CD, E. If I turn again, it lines up with E, F, G. Again, it's not perfect, but and if I turn again, it lines up with A, G, H. So first we're going to kind of identify that it is a rotation that is happening. Now, the first question is, describe a rigid transformation that takes triangle ABC, so my blue triangle, to triangle CDE. So what is happening that's taking ABC to CDE? Okay, and again, that's the rotation I was talking about. Now we want to figure out which way we are rotating. So I have to rotate clockwise and how much we are rotating. That is a 90-degree turn clockwise from the center of the square. So the answer that you kind of want to be writing out here is 90-degree clockwise rotation from the center of the square. Remember, you need to identify how much you are turning, so 90 degrees, the direction that you're turning, clockwise or counterclockwise, and then you need to identify the center of rotation, and I am identifying that by calling it the center of the square. The next question is, describe a rigid transformation that takes triangle ABC to triangle EFG. So I want to figure out how I get from here to here. Lay my triangle back on ABC, put my pen back at the center. We already determined this was a 90-degree rotation clockwise. If I keep going, that is another 90-degree rotation clockwise. So that ends up being a 180-degree rotation clockwise. Let's see if it matters, though, if I go counterclockwise. So if I go this way, it does not matter. So it doesn't matter if you go clockwise or counterclockwise, only when you are going 180 degrees, okay? So this time, I'm going to write it very similar, 180 degrees clockwise, or like I said, you could do counterclockwise rotation from the center of the square. And again, make sure that you have those 3 parts. How much, what direction, where's your center? Okay. Describe a rigid transformation that takes triangle ABC to triangle GHA. Now, we're kind of using the 90 and the 180 as our baseline. So if I keep going clockwise, I'm going to go past 180 degrees. You can do that, but if we're keeping with the 90 or 180 choice, I am going to go now 90 degrees counterclockwise. So that is how that's changing on this question. Okay, 90-degree counterclockwise, opposite direction a clock moves. Rotation from still using the center of the square. Okay, so that is how we're making our pattern, okay? With our rotations, they're all moving pretty much 90 degrees each time, figuring out if it's clockwise or counterclockwise. The last question is, do the segments AC, CE, EG, and GA all have the same length? And to explain your reasoning. So it wants to know, does AC, CE, EG, and GA, do they all have the same size? And how do you know? Well, think time. You can pause the video, think about it. What would you write? See if you write what I write. I would say that yes, they do. And how do we know? Well, because of the wording rigid transformation. Since we were using a rigid transformation in the directions, since we were using a rigid transformation in our questions, rigid transformations keep everything the same. It keeps everything congruent, same lengths, same size, same shape each and every time. So I would say something along the lines of rigid transformations do not change the side lengths of a figure. Okay, and during your rotation, every single time, this length of AC was still the diagonal each and every time that you were rotating it. All right, so hopefully these little videos of your three teachers going through each of the practice problems activities help you when you get to your practice problems and cool down.